everyone. I'm going to explain about the multi-tape Turing machines. Multi-tape Turing machine is a Turing machine with several tapes. Each tape has its own head for reading and writing, and each of the head is independent of the other heads. Here, in this case, the transition function is allowed for reading, writing, and moving the heads on the tapes. Initially, the input is on tape 1, and then the machine reads the consecutive symbol, and the machine prints a symbol on each tape and moves its head. Here we can see this is a multi-tape Turing machine with 3 tapes, so k is equals to 3. Each tape has its own head. Tape 1 head is pointing at A, tape 2 head is pointing at 0, and tape 3 head pointing at Y. The transition function here can be written as of the following form, where k is the number of tapes, q is a finite set of states, and the tape alphabet it contains at least the blank symbols and also having the input alphabet as a proper subset. Now, multi-tape Turing machines appear to be more powerful than the ordinary Turing machines, but we can prove that they are equivalent in power. Equivalent means that the language which is recognized by the multi-tape Turing machine M will also be recognized by a standard Turing machine S. We can prove the above statement is true by converting a multi-tape Turing machine M into a standard Turing machine S. The key idea here is to show that the S having a single tape simulates M, which has k number of tapes. So S simulates the effect of k tapes by storing their information on its single tape. It used the symbol hash as a delimiter to separate the contents of the different tapes. In addition to this, the contents of these tapes, the S must keep track of the location of the heads, and it does so by putting a dot below the appropriate tape symbols. This is done to mark as where the head on the tape would be. Here the figure shows that machine S is simulating a multi-tape machine M, and we can see that all the 3 tapes of multi-tape is converted into a single tape and shown in the standard Turing machine. Now to simulate a move of M, S scan its tape from the first hash to the k plus first hash in order to determine the symbols under the virtual heads. The S then scans the tape again to update the heads and contents according to M's transition function. If at any point S moves one of the virtual heads to the right onto a hash, this action signifies that M has moved the corresponding head onto the previously unread blank portion of that tape. S writes a blank symbol on this tape cell and shifts the contents to the right. Then it continues to apply M's transition function. If M accepts or rejects, then S accepts or rejects respectively. So as we saw that a standard Turing machine S with a single tape simulates a multi-tape Turing machine with k number of tapes, and it has been proven that every multi-tape Turing machine has an equivalent single-tape Turing machine. I hope this video helped you in understanding the multi-tape Turing machines.